Okay, so today we're working with the Pythagorean theorem, which is the formula of a squared plus b squared equals c squared. So with the Pythagorean theorem, we do have to realize that the only time that you can use this is for right triangles, and that's it. Right. So when we're talking about a right triangle, we have a couple specific pieces of the right triangle that we need to know about. The A side and the B side are what we call legs. And the longest side, side C, is called the hypotenuse. So we'll keep that in mind as we're working through these problems, as that may be some of the key vocabulary that may turn up in this problem. So moving on to exercise 1, it says solve for the missing side of each of the following right triangles. So hopefully when we get used to seeing the idea of a right triangle, then the idea would be like, I need to use the Pythagorean theorem to solve one of the sides. All right, so first thing we have to be able to do is to identify what the sides are. So this is side A, this is side B, and this is side C, which is the hypotenuse. Okay. The hypotenuse is always the side across from the right angle, so that's how we're able to recognize it. All right. So with that being said, all I need to do is to plug into the Pythagorean theorem. So I do 5 squared plus 12 squared equals c squared. Okay. So I'm just going to go right to the calculator, just in case you need to know where it is. There's a square button right here on the calculator. So as I type this in, I can type in everything as is. 5 squared plus 12 squared, and then just hit the enter key. Okay, so on my calculator it comes up to be 169. So that equals c squared. But that's not my end step. The last step here is to try to get rid of this square. So it has a special symbol. Square and square root are the opposites of each other, but the square root symbol is right here above the x squared key. So that means I have to hit the blue second key to get to it on my calculator. So the real side is 13. So 13 equals side C. So that's how long side C would be. Okay. All right. Moving on to problem B. Alright, so if I'm labeling it, here's side A, side B is the missing part, and then side C is my 20. So this one's slightly different. Alright, we still have two given values, but it's not the A and B this time. So when I set this one up, I'm going to call this one my unknown of x. Alright, so the formula was a squared, which is 12 squared, plus b squared, which is x squared, equals c squared, which is 20 squared from our triangle. Okay. So again, here I do 400, and this is 144, plus x squared. So minus 144, minus 144 on both sides this time. So I can't clearly add these two. Alright? So I'm going to do 400 minus 144. So then x squared equals 256. So again, the last step is to take the square root of 256. So square root of 256 is 16. Alright, so these so far have come out to be really, really nice numbers, meaning that these were all perfect squares. Both 256 was a perfect square, and 169 was a perfect square, which we're going to get to a little bit down in the bottom part of this page, where we have some that are non-perfect squares. Right. So for any right triangle, again, if you need to find a missing side of a right triangle, you would use the Pythagorean theorem. So this is my side A, this is my side B. So I'm going to do, and then this is my side C. So I'm going to do a squared, which is 5, so 5 squared, plus 5 squared, equals c squared. And then you can just stick this right in your calculator. Alright, but I get 25 and 25, and that makes 50. So I get 50 equals c squared. and then I would take the square root of 50 to get the regular c. Now for this part, this is where I would need to break down the radical 50 into what they called simplest radical form. Right, so when I'm thinking about that, I need to start thinking about, okay, what are my perfect squares? Well, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, and then it keeps going. So where am I getting these perfect squares from? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9. So they're all the whole numbers from 1 to 10 that have been squared. What I need to figure out is which one of these will go into 50. Well, 25 does. And that would be 25 times 2. Okay, so the square root of 25 is 5, and then we just leave the radical 2. So that's the idea of, oh, this one I can break down into simpler form, and then the other one I leave in a radical form. So simplest radical form was the idea here. Alright, so I'm going to move on to the next one, part B. Again, identify the parts of your right triangle. There's the side A, there's the side B, here's the side C. So I'm going to do a squared, which I don't know, so I'm going to call that one my x squared, or you could leave it as a squared. B squared is 4, and c squared is 8. So this is very similar to the problem that we had done up here, where we had side C and we did not have one of the legs. So as I solve this, I need to solve it in the same manner of actually subtracting the 2. Okay, so x squared equals, and I'm going to do 64 minus 16, and I get 48. So again, with this problem, we always have to take the square root at the end, right? So if I need to break this into simplest radical form, then I'm going to look for a perfect square that goes into this. Now I may need to test them. Well, obviously I'm not going to use 49 because it's way too high, so I'm going to start with some of the lower numbers. So I'm going to attempt to do 48 divided by 25. That does not go into it nicely, so I cannot use that as my perfect square. Okay. Alright, so then I'm going to do, let's try the next number down, which is 16. So let's try 48 divided by 16. Yep, that goes into it nicely, so that's the pair I'm going to use. So 16 and 3, and then 16 breaks down, so this becomes 4 radical 3. Okay. Now if you have to round it to the nearest tenth, that's where you would do the actual square root of it, and then round that. Now remember, this 9 is in the tenths place, so I look to the 2. The 2 is not high enough to round the 9 up, so I leave this as approximately 6.9. So that's what you would do if you needed it in the nearest tenths place. Alright, so that covers the first part of your notes. So now I'm going to move to the back page, where it goes into a little bit more of the idea of an actual real-life situation. Alright, so it says there's a 12-foot ladder, here it is, leaned against a wall it's 4 feet from it. Okay, how high up on the wall will the ladder reach? So they're looking for this part right here. So if I should recognize in the picture, we can see that a building with the ground makes a 90-degree angle. So then this would be my A, this would be my B, and the 12 would be my side C. Now if you mix the A and B up, you're okay, but you cannot mix it up with the C. So now, the instructions here just ask me to round it to the nearest tenth of a foot, so therefore I'm not going to put it in simplest radical form. Okay, so here, a squared plus b squared equals c squared. A squared plus my b squared, which I don't know, equals the actual ladder of 12 feet squared. So this is very similar to the second problems from the front page, where I would get 16 plus x squared equals 144. Okay, so I'm going to take 144 and take away 16 from it. And that's where you get x squared equals 128. And then my last step would to take the square root of 128 in my calculator. Okay. So again, it asks me to round it to the nearest tenth. The 3 is in the tens place, but the 1 next door is not enough to round it, so I would leave it as 11.3, and that would be my side C. And that would be the final answer. So it reaches approximately 11.3 feet up on the wall. That would be the height of my wall then. Okay, going over exercise 4. Right, so it's got more key vocabulary in here, where it first starts off with an equilateral triangle. So if you're not familiar with what an equilateral triangle is, it's a triangle with all equal sides. Okay, so if I draw this triangle, it's going to have the idea that all these sides are 10. Okay, and it's going to ask me, what is the area of the triangle in simplest radical form? Okay, well, first thing first, I have to know what the area formula is for a triangle. That's 1/2 the base times the height. Well, in this case scenario, I know what the base is. The base is 10. My problem is that I don't know what the height is. Okay, so I'm going to draw the height in the triangle. I'm going to draw this height down, and it's going to connect with the opposite side to form a 90-degree angle. Okay, but something else about this line, okay, it's also called the altitude, but it's also going to split this into 2. So it bisects that line at the bottom. Okay. And if you haven't figured it out right now, you can see the beautiful thing that was created was the idea of the right triangle. And the height is the missing side here. And this is 5, and this is 10. So then that's going to become the idea of a squared plus b squared equals c squared. So that's exactly what I'm going to do. I'm going to do x squared plus 5 squared equals 10 squared. So x squared plus 25 equals 100. So then I subtract the 25 from both sides, and I get x squared equals 75. And then I'm going to take the square root of it. So it's going to give me the square root of 75. Okay. Now I'm going to break this 75 into simplest radical form like the instructions said. Okay. 25 is the perfect square that goes into 75. So it becomes radical 25 times radical 3, which this becomes 5 radical 3. Alright, so now I'm going to plug that in to over here to find that area. 1/2, the base, the whole thing is 10, times the height that we just wound up having to find, 5 radical 3. Okay. So this radical 3 is actually going to stay. I'm not going to do anything with it. I'm not going to put it in the calculator. I'm just going to do 1/2 of 10 times 5. Well, 10 times 5 is 50, and half of that is 25. So this becomes 25 radical 3. Okay. Alright, so I'm going to stop there, and we will further discuss number 5 in a different lesson.